So we're moving to a new phase of the course, part 3 of the course, and that's starting to look at separations, particularly vapor-liquid separations. So we've dealt a lot with various material balance problems where we have one stream which is a mixture of various components, and it goes through some unit, or some processing unit, and it's separated into two or more streams in order to generate more pure product streams or more pure streams of a particular component. And this is really what a lot of chemical engineering is built around, is separations, trying to take something that's separated from something else. For instance, if you have the wrong type of chemicals in your gasoline and you put it in your car, you can ruin your engine. So you want to have pure gasoline, or at least keep contaminants out of your gasoline. When you're eating food, you don't want there to be particular chemicals in your food that may be bad for your health, that might be poisoning you. So when people are processing food, they have to make sure that they separate or remove any sort of contaminants or poisons or whatnot. And the list goes on about various reasons why we want to have pure components, or at least components where certain parts are removed. So let's talk about different ways that you can separate materials. So one method is to have some sort of physical barrier that prevents one chemical from crossing the barrier. So here is an example where I might have some feed that's a mixture of one or two or more different chemicals, and one of those chemicals is able to cross this barrier, which I've shown here in blue, and we're able to take it out as this exit stream right here, whereas other components can't cross the barrier. And typical barrier would be some sort of membrane, and the membrane, it only allows certain molecules. Maybe that's based on the molecule size. A membrane may have little holes in it that only allow small molecules to go across this barrier. Or it may be based on their chemical properties, whether that chemical is hydrophilic or polar or whatnot. And so that's one way that we can separate, is using barriers. Another method I just want to talk about is using some sort of force or a gradient in force to separate materials. So if you've ever worked with a centrifuge, then you know what the concept of this is. So a centrifuge is essentially a device. Centrifuge is a device that spins really, really fast. I mean, super, super fast. And what happens is, if you put these materials in this spinning centrifuge, it spins around, that you tend to have the things that are heavier, or more dense actually, they tend to move towards the outside of the container. So the typical centrifuge is in some sort of cylinder, and what will happen is the materials that are heavier or more dense will tend to concentrate on the outside, and on the inside we'll tend to have materials that are less dense. And so we're just separating them using the force, its spinning motion, the spinning force that's pushing the heavier or more dense materials to the outside of the container. And that's a centrifuge, or using something by force. So the last method I'm going to talk about for separating different chemicals is through phase creation. And this is the most mature, the most commonly used method for separations, and it's what we're going to be spending this next part of the course on, where we have some sort of feed and we create two or more different phases. In this case, what we're doing is we're creating a vapor phase and a liquid phase. And what will happen is that some of our chemicals will tend to go to the vapor phase, some will tend to go to the liquid phase. And because of that, we can create a separation between the two streams, which means we can separate different chemicals. And this is what we're going to concentrate on for the next part of the course. So we're going to spend a lot of time in the next few days, and for the last part, talking about the properties of vapors and liquid in equilibrium with each other, and how vapors and liquid come in contact, and what type of properties we can expect, and how we can expect separation between a vapor and a liquid phase. And that's what we'll be working on again for the next part of this course now.